The digital world is full of increasingly amazing things. There are self-driving cars, phones that turn our voice into text, and robots that trade stocks on the market, and so on. How is all this possible? Of course, the full answer involves many inventions, microchips, sensors, and much more. But a large part of the explanation comes down to one concept: algorithms. An algorithm, no matter how complex or technical it seems, is just a sequence of instructions. It's as simple as that. Instructions for what? For anything. What matters is having an initial state, an input, and following a sequence of steps to the letter. To always produce an output, of course, all this sounds very abstract. But in practice, you realize you already know this concept. Do you still remember how to multiply with pen and paper, step by step? Basically, you start from the right, multiply number by number, carry the tens, and add to get the result. Well, that is an algorithm. The input is what you want to multiply. Let's say 65 times 34, the output is the result of the operation. And the algorithm itself is the steps we learned in school, but let's not stop at the description. Let's see the algorithm running. We start with the units. 4 times 5 is 20. We write down the 0 and put the 2 in the tens column. And voila, 2210, you might have no idea what you're doing. As long as you follow the steps, you will reach the correct result. Now think about how that applies to many things, and that much of the knowledge we share takes the form of a sequence of steps. For example, a cooking recipe is an algorithm. The input is the ingredients. The output is the finished dinner. And again, the algorithm shows how to move from one state to the other. There are algorithms for getting ready in the morning, changing a light bulb, or catching a bus. And in general, if you look for instructions in the things we do, you find them everywhere. The beauty of algorithms is that they let us get results without understanding what we are doing. But they also allow us to communicate complex tasks without explaining the why. We have always needed that, but it is especially useful now, as we have an interlocutor that understands absolutely nothing, yet is perfectly capable of following millions of computer instructions. Programming is the art of turning things we do, or want to do, into a sequence of instructions that a computer can process as an algorithm. For that, we use logical languages with variables, functions, and loops, among other things. Curiously, this puts us on the uncomfortable side of history. The one following instructions can afford not to understand what they are doing. But the one designing the instructions, us, or rather programmers, must reach a very deep level of understanding. And yes, it is hard to instruct a human, someone who can figure things out on their own, someone who interprets information based on context. Now imagine the challenge of instructing a computer. To a person, I can say, fill the kettle, put it on the stove, and turn on the heat. When it makes a noise, turn off the stove and pour the water into a mug. To a computer, I must define what a kettle is, where it is, and what on the stove means. And a million other things. Designing an algorithm is an immensely creative task. And every answer we find for a specific problem is a solution we can replicate infinitely. The result is that we are constantly interacting with something. And interestingly, these algorithms don't just make life easier, like sending emails or online payments. They also modify our decisions. An algorithm recommends books on Amazon. Another gives you Google results. A third tells you how to drive your car. And how is such a feat achieved? With instructions many, but all simple. Ultimately, the most interesting thing about algorithms is that they are a solution to the problem of how to automate any given task. A solution that can be elegant and amazing. But they are also a way to manipulate our surroundings through computation. They also highlight the way we interpret the world. Where does that path lead us? What will we automate in the future? That remains to be seen. But looking back, consider that evolution in its own way is an algorithm. The input is matter. The instructions are reproduction, mutation, and selection. And the output is the diversity of all life forms that exist. By the way, if any of you are interested in explaining ideas with a video like this, we recommend you visit our website at magicmarkerspro.com. And for those who don't need to order an explanation but want to support us, feel free to subscribe to this channel and share our videos. That helps us.